All right, guys. So today we're going to talk about momentum. We're going to talk about momentum. Now, momentum is something that we experience every day. Let's say you are running, right? Let's say you are running. This is you. You are running in this direction. Speeding. Let's say you are running, speeding. Okay. And then all of a sudden you are told to stop. You have a problem to stop. So you are running here, and then all of a sudden you are told to stop. So you have a problem, especially if you are speeding. You have a problem to stop. Why? The reason is because of momentum. So when we say momentum is a quantity of motion of a moving object, how much are you moving? So the more you are moving, I mean, the speed, the amount of speed you have, okay? The more the speed that you have, okay, the harder it will be for you to stop. So momentum is actually, is this the quantity, is the quantity of motion of a moving body, okay? So the more momentum a moving object has, the harder it is to stop, okay? So that's what momentum is. So momentum is actually calculated in mathematics. In this course, in this topic, momentum is calculated as mass times velocity. That's how we calculate momentum. And if we are talking about the change in momentum, so that's how we calculate momentum. So if we are talking about the change in momentum, so the change in momentum would be mass times final velocity minus mass times initial velocity. Okay, the change would be like that. Okay, if you are given an example, let's say you are told that you have a particle of mass 4 kg. Okay, this is a particle of mass 4 kg and has the initial velocity of 5 meters per second. Okay, and then you are told to find the momentum of the particle. So momentum will just be mass times the velocity, which is 5, and that will be 20. Now, momentum's units are newtons, newtons seconds. So it will be 20 newton seconds. That's momentum, okay? Very easy. That's momentum, okay? And so, but if I'm told, if you look at a second example, if I'm told we have a car of mass, let's say we have a car of mass 20 kg. Now that's a very light car, 20 kg, with a speed of, let's say, 20 meters per second. Okay, then it later increases the speed to 30 meters per second. So it increases the speed. So if we want to find the change in momentum, the change in momentum now will be mass, which is 20, times the final velocity, which is 30, minus mass times the initial velocity, which is 20. Then whatever we are going to find, so this is 600 minus 400, gives us 200 newtons per second. Okay, so momentum is just mass times velocity, okay? Or mass times final velocity minus mass times initial velocity. That's momentum, okay? That's momentum. So always know momentum is just mass times velocity. Mass times velocity. That's momentum there. Now, this is easy. There's the second part of momentum where you are dealing with objects colliding. Objects colliding. What do I mean colliding? So what I mean by colliding is that, let's say we have an object A here, which is moving in that direction. We have another object here, which is moving in that direction, right? So let's say this object has mass 2 kg, and it's moving in this direction at a velocity of 3 meters per second. We have this object, which is, let's say, 4 kg. It's moving at 2 meters per second. Okay, that after they collide, let's say maybe after they collide, what happens is that this changes after they collide. Let's say it changes the direction. It's now moving in that direction. This doesn't change the direction. Let's say this changes the direction. Now the velocity, the new velocity after collision is 3 meters per second. it has changed the direction. Now remember, it has changed the direction, right? It has changed the direction. And so since it has changed the direction, this is negative, right? Because it has changed the direction. Let's say this is 6 meters per second. It has not changed the direction. So it's positive because we are talking of, yeah, initially it was moving in that direction there. So here, let's say initially it was moving in that direction there. So when we say it has changed the direction after collision, so it's negative there, right? So if you are dealing with colliding objects, momentum, okay, momentum is actually calculated using a principle we call conservation of momentum. Conservation of momentum. So if we are dealing with colliding objects, we calculate momentum using the principle we call conservation of momentum. This principle says that momentum before collision, okay, and after are the same. So in short, total momentum before impact and total momentum after impact are the same. So before impact, momentum before impact is the same as momentum after impact. So that's what the principle says. That's what this conservation of principle says. So before and after are the same. And it uses the formula which looks like that. The mass of the first object times the initial velocity of the first object plus the mass of the second object times the initial velocity of the second object. This should be the same as the mass of the first object times the final velocity of the first object plus the mass of the second object times the final velocity of the second object. Yeah, so it's like that. So that's how it's calculated. So let's say we have two objects. We have this object A here. We also have another object B here. So let's say before collision, this is moving in that direction at 5 meters per second. 5 meters per second. Let's say the mass of this object is 2 kg. Okay. And this object B here, okay, of 8 kg, this is before collision. It's also moving. Let's say it's stationary. So meaning 0 meters per second, right? It's stationary. Okay. So this is before collision. This is before impact. Okay. Then after collision, let's say this object here, object A, it changes direction. It's now 3 meters per second. Now remember, it has changed direction. So pay attention that that should be negative. And let's say this one has maintained the direction. So this is 2 kg object. This is 8 kg object. So this has maintained the direction. So let's say the direction is v meters per second that we have to calculate. Right? So here we are talking of momentum before collision. Here, momentum after collision. So momentum before is what's the mass of the first object is 2. What's the initial velocity of the first object is 5. Right? Plus, what's the mass of the second object is 8. What's the velocity of what's the initial velocity of the second object is 0. And this is equal to the other side. What's the mass of the first object, guys? It's 2. What's the mass of the final velocity? It's 3, but remember it's in the opposite direction. So it's negative 3. Plus, what's the mass of the second object, guys? It's 8. What's the velocity? It's v that we are calculating for. So it's like we have formed an equation, right? You guys should know how to solve equations because this is equal to that. We can solve for v, find v, and confirm that v is equal to 2 meters per second. 2 is equal to 5 meters per second. I mean 2 meters per second. That's what we are going to find. Okay, so that's velocity. Okay, I mean, that's velocity. So that's about momentum. So to answer questions on momentum, you always have mass and velocity. If you don't have them, we have learned all formulas that we can use to find velocity or anything else that they're asking us. So mass times velocity, that's momentum. Okay, if you're dealing with two objects, you have the mass of this object. You also have its velocity, which is the initial velocity. You have the mass of this object. You also have the initial velocity of this object. Okay, you have the final velocity of this object. You also have the final velocity of this object. Then you can use now the formula that we have just talked about, which is this mass of the first object times the initial velocity of the first object plus mass of the second object times the initial velocity of the second object. This should be equal to mass of the first object times the final velocity of the first object plus mass of the second object times the final velocity of the second object. You equate this equation and solve what they're asking you to. So try to do now the questions and the exercises in the textbook and see what you can do. Please always make use of past papers. Try to go through some past papers and answer some questions. All right, guys, thank you so much for your time and enjoy.